All right, welcome. So we're going to start in chapter 8. This is basically series solutions to differential equations. Okay, so let's actually start with just a couple that we should already know or should be familiar to us. So let's start with e to the x. Okay, now y equals e to the x. It has a Taylor series. We know it's Taylor series. This is 1 plus x plus 1 over 2 factorial, which is 2x squared, plus 1 over 3 factorial, x to the third, so on and so forth. Okay? So, in general, remember the Taylor series. For f of x about x equals a is f of x equals f of a plus f prime of a times x minus a plus 1 over 2 factorial f double prime of a x minus a squared keeps on going forever, and we can sum that up nicely in this term, or in this form. N goes from 0 to infinity, 1 over n factorial, the nth derivative at a, x minus a to the n. Okay, so that's our basic Taylor series. Okay, so let's go ahead and look back at this e to the x. So we know that y equals e to the x actually solves a differential equation. Let's actually do y equals e to the kx. It solves y prime equals ky, okay, with y of 0 equals 1. Okay, so let's start, and what we're going to do is we're going to actually do this via, we're going to find the Taylor series. Okay, we're going to find the solution to this via the Taylor series. We already know how to solve it. We're going to do it via the Taylor series. Okay, so we're going to pretend we don't know this. Okay, so let's black that out. Let's pretend we don't know that. Okay, and what we get is, so let's start. Y of 0 equals 1. Now, y prime of 0, y prime of 0 equals k, right? Because y prime equals k times y. Okay, now let's take the derivative of that. So if we take y prime equals ky, where k is constant, that means y double prime equals k times y prime, right? So y double prime of 0 equals k squared. Okay, I'm getting somewhere. Y triple prime going to equal k y double prime. So y triple prime at 0 equals k cubed. Okay, now we're starting to get somewhere. Now, what we can do is we can use the Taylor series about x equals 0. Okay, we sort of already have an idea of what's the nth derivative at 0. That's just going to be k to the n. We can figure that out. That's not a problem. So what is our series? We're going to have 1 plus k plus, remember, there's that 2 factorial there. So it's going to be 1 over 2 factorial. Oh, I forgot my x, by the way. Sorry. Oh. Okay, so here, f of 0, f prime of 0 times x plus 1 over 2 factorial k squared x squared. It's going to keep on going like that. So it's going to be the sum. N goes from 0 to infinity. Okay. 1 over n factorial kx to the n, which equals, of course, our y equals k to the x. Okay. All right. Do the same sort of thing with sine and cosine, or with, right. Okay, so let's consider y double prime plus omega squared y equals 0. And we'll say that y of 0 equals, let's say, a, and y prime of 0 equals b. Okay, so we need both of them, right? It's a second order differential equation, so we need 2 initial conditions. Okay, so now let's take and start. So y of 0 is a. Y prime of 0 is b. Okay, now we have y double prime. Well, y double prime equals negative omega squared y. So y double prime of 0 is going to be negative omega squared a. Oh, sorry, negative omega squared. Yes. Let me just check that. Let me not write this as a. Let me write this instead as alpha and beta. I don't want to get stuck into this a here. Okay, so that's a. So now negative omega squared alpha. Yes. Y triple prime of 0 is going to be negative omega squared beta. Okay, so far okay. Let's go one more. Y, the fourth derivative at 0 is going to be, that's going to be omega to the fourth times, well, let me write it down. So the triple prime was negative omega squared y prime. That's what we had here. Okay. The y to the fourth is going to be negative omega squared y double prime. So that's going to change the sign here. So it's going to be omega to the fourth times alpha again. Okay. Y to the fifth, let's do that last one, equals negative omega squared y triple prime. Okay, let me write that with a 3. Okay, so that's going to be omega to the fourth beta. Okay, now let's start building our Taylor series. We're actually going to have 2 different ones, right? This one is going to lead us to, let's write, let me bring this down. put it in orange. Okay, so this one, we're going to have alpha, that's y of 0, plus, now f prime of 0 is going to be beta times x. We're gonna write it into, we're gonna write it as as the one, and then we're gonna actually find that we split it up. Plus 1 over 2 factorial f double prime negative omega squared alpha times x squared. Okay, f triple prime 1 over 3 factorial negative omega squared beta x cubed. Okay, let's do a couple, last two. Move them for no reason. Plus 1 over 4 factorial. Okay, the 4, that's this one. So we're going to have omega to the 4th alpha x to the 4th. Plus 1 over 5 factorial. That's going to be omega to the 4th beta x to the 5th. Okay. I just moved that down so that I could see it, but I'm going to get rid of it now because it was up here anyways, so you guys could see it later on your notes. Okay, now what I'm going to do, I'm going to split this up into the terms that have alpha and the terms that have beta. Okay, so the alpha terms are going to be alpha times 1 minus 1 over 2 factorial. Let's write this as omega x squared, okay, plus 1 over 4 factorial omega x to the 4th. And you can see that's going to continue in that way, okay? Plus, let's take the beta out. Now here, one of the things that I want to sort of do is, you may have noticed I have the omega and x at the same power. And I want to have that sort of happen here too. But here, you might notice that there's no omega here. The omega here is 1 power less than this. Same here. So what we're going to do, we're going to pull out an omega too. We're going to divide by an extra omega so that we can multiply an extra omega into my term, my sum. Okay. Multiplying that extra omega, and I'm going to get x. That's, oh, sorry, that's this first term. Okay. Minus 1 over 3 factorial. Now I have an extra omega I took out, so that means this omega is going to be omega cubed. And I can write that as omega x cubed. Oops, I almost forgot to put an omega on here. Don't hate me. Okay. Plus 1 over 5 factorial. This term, right, that's going to have, this term, that's going to be omega to the 5th, x to the 5th. That's going to keep going. And you may or may not remember that, or you may or may not recognize that as this is the Taylor series for cosine. This is the Taylor series for sine. Okay. All right. I'll see you in the next video. We'll do some more problems like this, or we'll actually do some problems with this.